Hey Bio4 people, we're back to muscles part 4 and we're going to look at the solution to these prime movers for squats. So the first thing I want to show you are the hip flexors. So there are quite a few muscles here that you haven't learned yet that are crossing this joint of the hip, and they're the ones that are the prime movers for you to stay in this position here over this flexed hip. So hip flexors, and then we have hamstrings. Let me get my color here, my pen color. So hamstrings and glutes and quads that were already shown here, and quads. So those are all the very important muscles that are keeping you in that squat. So that's prime mover, prime force. And then synergists, if you came up with this. So synergists, let's change here to green and go to lower back here, upper back. So we've got all of these muscles at the back. They're going to make a difference. Abs, abdominals, and calf. So these are all the muscles that are keeping you in that position, both the prime movers and the synergists. Hard to do. Okay, side bends. The side bends, prime mover, internal and external obliques. So these are muscles here that are oblique. You have one in one direction, and then the other one is coming in the other direction. And it's these internal and external obliques that are the prime movers for a side bend. And then synergists are abdominals, and I can't show you, but upper and lower back. You can figure that one out. Yeah, don't have a picture for it. Good. Okay, now we're going to switch gears and we're going to go small. We're going to go tiny, really small. We're going to look at muscle at the molecular level. Okay, this that I'm showing you here, how many cells can you see? One. This is one cell. This is definitely more fun to do in person because people are counting the inside here, the microtubules, to tell me how many cells are here. But look, this is a nucleus. Here's another nucleus. This is one cell. Okay, so we're going to look at the inside of one cell that's a skeletal muscle cell. And these round sections here are myofibrils. Myofibrils, each one of these. And each one of those myofibrils is made up of myofilaments. And sticking out like straws here are these myofilaments. You would see them here as the dots. The dots because they run the extension here of the muscle. So different from fascicle when you're thinking of the entire muscle. Okay, here we're thinking of one cell, and it's made up of these myofibrils that in turn are made up of myofilaments that in turn are made of protein. So the first thing I like to point out is that this does not look like Joe's cell. You know, Joe's cell that I draw is circular, and he has a nucleus in the middle, and then he has some mitochondria like this. That I recognize as Joe's cell. This I don't recognize, correct? And it's true. It's a cell that's very different. It's very specialized. It's specialized to do one thing really, really well, and that is contract. And so it has to have all these proteins arranged in this parallel form here that's going to allow them to take this big bundle muscle that you have, your biceps brachii, and contract it or shorten it. And so it takes a huge specialization on the part of that cell to be able to do that. It doesn't look anything like a cuboidal cell, right? It's different. It's going to be very different. So in this diagram, again, we do have some of the structures that you would recognize in Joe cell. Here's a mitochondria, right? They're sort of spread around. The nucleus, it's got various nuclei, but the nucleus would be here. And then, as we look at these myofibrils with the filaments, we see that these filaments are arranged in parallel manner. And finally now you know why when you looked at skeletal muscle under the microscope, you had striations. What is it that you're seeing in the striations? Well, as long as you have all these parallel proteins that sometimes overlap a lot and sometimes don't overlap at all, these are just the red ones, then you're going to see bands. You're going to see under our microscope that doesn't come anywhere near being able to see this. All you're going to see is stripes or striations. And it's because you are seeing this thick and thin filaments here in a special arrangement. But our microscopes are very bad. I mean, they go up to 1,000 times magnification, but still that's really not good enough to see all this. Okay, so the banding that you were seeing had to do with the arrangement of these filaments and how you see them sometimes crossing over each other and it's going to look like a dark line, or not crossing over each other and it's going to look like a lighter line. Okay, on this diagram I need to show you more structures. This blue network here around is a modified endoplasmic reticulum. It's not like the other one that had the ribosomes on it. It's called a sarcoplasmic reticulum, and it has a very important function, and that is it stores calcium. And you need calcium in muscle if you want it to contract. Okay, so if you're going to need an endless supply of calcium, then you better put it somewhere, and that's where you're going to put it, in the sarcoplasmic reticulum. The rest, we're going to look at that detail in a little bit, right? It's all these structures with parallel proteins. Okay, so the striations, so coming back to these striations that we showed you. Myofibrils are lined, giving these distinct bands. So now I show you again how I have a thick protein that's in purple, thick in parallel, and then these orange ones that are thin. And notice lots of overlap here, not so much overlap here. So dark, light, darker, light, and that kind of banding is what's going to give those striations. For the names of these, this is an I band, which is a light band, because you don't see any of the thick filaments, so that's I. And then A, we're going to include, the A band includes anything that has, this is all going to be dark because it has the purple protein here, making it a dark band. So the lighter areas and darker areas. We introduced the name sarcomere, and sarcomere is this repeating pattern of overlap that you have in your muscles. So the end of that region is called the Z line or the Z disc. Look at this, it's in a Z here. And from there, all the way to where it gets to the other Z, which is right here, is going to be one sarcomere. And that translates into a contractile unit, which means that's the smallest piece of your muscle that can actually on its own contract. It has that function, it's able to do it. It's going to drag these others, this location 1, if we call this 2, and then there's going to be a 3 here, right? It's going to drag it with them, but they're all contracting at the same time, and they're all in parallel. So just keep that thought for a little bit. Okay, if we increase the size of this, I'm going to tell you more information. The thick filament is the myosin, purple and dark. And it's a very huge protein. And it's going to be responsible for sliding this thin filament over it. But a little more on that. Let me just look at the myosin more closely. So a myosin protein is like this on the bottom here, where it's a coiled protein with a head. But it's actually two of them. So two heads coiled with a tail. They look a bit like a golf club. So if you were to take and put hundreds of these golf clubs together, it would look more like that, correct? With all the little heads coming up and all the tail part arranged along this myosin chunk of protein. Okay, so we've arranged the protein there in these parallel layers, and now in between those, in orange here, are the thin filaments. And these are a different protein altogether. This one's called actin. Okay, and actin then is going to have some overlap with myosin. Some overlap with myosin, but there's going to be zones that are bare. And when you have a contraction, what happens is that the overlap increases. So this thin filament is going to move this way. And this thin filament is going to move that way, and this bare zone is going to become smaller. So envision this whole thing moving, and this moving, actin, and it's going to slide over, making that bare zone smaller. I'm going to stop there and continue on in the next slide, giving you even more detail of this. We're going to jump into it with even more detail. Thanks for listening.